interesting problem from, I think it was the MIT Harvard math competition. And you got this strange looking expression here. It's a sum of a couple of square roots. And we want to find the smallest possible natural number. Natural number is like 1, 2, 3, just the positive integers, such that this expression actually evaluates to an integer. Okay, so this bunch of square roots, and it's going to evaluate to an integer. If we want to find the smallest n, this is a function of n such that occurs. Now, I want to square both sides. I left out some of the steps here, but the identity that I used, there's two actually. I left one out here, it looks like. The 2 comes from the fact that we have a 2 in this well-known binomial identity, and also we use the truth that a squared minus b squared is equal to a plus b times a minus difference of 2 squares comes up. And you can see why that would occur here, because you have the conjugates up here, 144 plus square root of n, and then 144 minus the square root of n. So you would, this comes in quite handy, and you can see how we end up with this. It's not quite as bad as it looks. So a plus b times a minus b. So both of these well-known algebraic identities were used in squaring all of this and getting to this statement right here. Okay, now, the first big observation here is the smallest n will occur when our expression, this simplified expression here, is largest. Now, I won't try to explain that too much, but there's no way that this could be a very big number if n was a large number, right? So it will be the smallest n such that this condition is satisfied. Now, that's still not quite enough information, but what we can also surmise is n would have to be in this set. Notice that n couldn't be 144 squared, because you would get the square root of 288 up here, I think. Okay, you could say, I think you would get the square root of 288, which is not a perfect square. And so we have to stop just shy. So n would be a number in this set, all right? And also by closure, everything up here is an integer. So that means the radical itself must be an integer, all right? And again, the possible values of n would be 1 through 143. Again, we have to stop shy of 144, okay? So these are the possibilities for the value of the square root function. And so the value of the square root function, for it to be an integer, it would be one of these 143 integers. And so what we do right here to kind of get a grip on what an upper bound would be is we actually replace this with the largest number of 143 right here. Okay, this 143 that you see right here, this is just to get an upper bound. Now, when you multiply this out, you get 574. And notice right here that 574 is less than 24 squared. 24 squared is 576. So 574 is less than 24 squared. Now, let's see, did I tell you that it has to be even also by this statement? K would have to be even, since 2 times anything is an even number, and for a square to be even, the value itself has to be even. So K is even from this statement. 574 is less than 24 squared. So 22 squared is the next smallest square, and that's where this 22 squared came in. Okay. Now, the rest of it is just manipulation. You're trying to isolate and figure out what the value of n is. Now, from this statement right here, if you square this object and you square this object, you will get, let me write it down on the next line here, you will get that n is equal to 144 squared. Minus 98 squared. Okay. Now you'll notice that's in our set of anticipated values, right? That's in our n would have to be in this set, and certainly this value is contained in this set right here. And let's see, y'all, the arithmetic on that gives you, I just used the calculator here. You know, I guess you could do some different, you could do some difference of two squares and turn it to addition and subtraction and get an answer. But I just used the calculator, and you got the answer is 11,132. And y'all, this is an interesting problem. There's some other values where you get squares, but this is just the smallest one based on this analysis up here. So 11,132, a very large number, but that's kind of believable when we're dealing with square roots here. So that is the answer, ladies and gentlemen, 11,132. Let me know what you think.